Hello, my name's Caitlin Valor. I am doing this video for Professor DeNova's Fall 2020 online physics class. And I am going to be demonstrating an electrical circuit, and specifically I'm going to be demonstrating the difference between a series circuit and a parallel circuit. So here we have an example of a series circuit. So we have the batteries, which is our voltage source, a power switch that slides on and off. We have the lamp, and we have a motorized fan. So the electrons are going to flow through the circuit, and they are all of the components are connected in series, which means that they are dependent on one another. So as you can see, this switch is going to control both the lamp and the fan. If one of these were to be disconnected or broken, if the light bulb wasn't working, or the fan wasn't working, then the flow of electrons would be disrupted and nothing in the circuit would operate. This is how a series circuit works. It's similar to the old-fashioned Christmas lights. When one light goes out, all of the other lights on the strand go out. So as you can see this again, put the switch on, both the lamp and the fan operate, and then they both shut off. This is an example of a parallel circuit. So we have the voltage source right here where the batteries are, and the current is going to flow in between each of these pathways, okay? So there is a lamp on one pathway with a control switch right here, okay? And then there's a separate pathway with a separate switch for the fan. That's the motor fan. Connect that. So what happens is that each of these switches controls the separate paths. Now, if something was to happen to the lamp or to the fan, or if the circuit path was disconnected, the other path would still operate because they are running independently of each other. So if we were to disconnect this path, for example, the circuit that the lamp is on is disconnected, but the other circuit runs independently and the fan still operates. And similarly, we reconnect and we can disconnect this path and turn the switch on, and the light still operates. This is how parallel circuits work. One more thing I wanted to point out, I was not able to actually show this in my demonstration, but it's something we did learn about, and I wanted to mention at the end of my video, is that when we have the series circuit, the voltage that is going through the circuit, it gets divided up between the different electrical devices. So the different voltage drops to the lamp and to the fan add up to the total voltage of 3 volts, which is the power source, the power coming from the battery. Whereas in the parallel circuit, the voltage that is distributed to each electrical device is the same. It is the current that gets divided up. In this demonstration, I did not have a way to measure the current going through each device, but it should just be noted that that is a major difference between series circuits and parallel circuits. There is also less resistance in the parallel circuits because there are less devices on each path. So in a series circuit, you have one path with a bunch of different devices, and each of those devices actually causes resistance in the circuit. So when we had 2 devices on the same series path, that there's more resistance in that path, whereas opposed to the parallel circuit where there is less resistance throughout the entire circuit because it is divided up in between all of the different paths. So back to the grocery store line example, there is less resistance, less traffic, less of a wait in line if there are more registers open, as opposed to if everybody's trying to feed through one register. Another interesting thing to point out, one of the concepts we learned about, is that increase in temperature causes more resistance. That is why when you first turn on the lamp, it's initially brighter and then a few seconds later it dims. You can see that happen with this light bulb here. Did you see that? it's bright and then it dims a little. Bright and then it dims a little. And also, once we use the fan, you'll see that the light will flicker and dim a little as well, because now the current is going through each individual path. So some of the power is being used to operate the fan. When the fan is off, the light is brighter. When the fan is on, the light is dim. Another interesting concept we learned about is the flow of electrons in an electrical circuit. The electrons are flowing from the negative terminal to the positive terminal. So we know that they are moving this way in the circuit. So what we learned is that there are major differences between series circuits and parallel circuits. In a series circuit, all of the components and electrical devices are connected along a single pathway, and the current is going through that single pathway from one terminal of the battery source to the other terminal. All of the voltage along each device that's going through each device adds up to the total voltage of the circuit. And there's more resistance in a series circuit because each of the components are on the same path, are all adding resistance, and they all add up to the total resistance of the path. In a parallel circuit, the pathways are divided up into different branches of multiple pathways. So we had a separate pathway for the lamp and a separate pathway for the fan. This causes less resistance overall. The total resistance is lower, and the voltage is the same across each device. So each of the devices run independently of each other, and if there is a disconnection or a malfunction in one of the branches, it is not going to affect the other branches. So back to the supermarket example, just imagine if the line next to you, the register breaks or the person has a bunch of coupons, it's not going to affect what's going on in your line because you're running independently. Also, in a parallel circuit, it is the current that gets divided up in between each path. So the current in each branch is what adds up to the total current of the entire circuit. So just remember when you're hanging up Christmas lights this year that you might want to use your newer lights that run on parallel circuits, because if you use the old lights and one bulb goes out, they all go out.